Yes? Thank you. Read what I'm writing here. I'm very bad with typing. Do you have any questions? Question about time? You understand time? If you understand time, you have understood everything. Okay. This keyboard. Okay? So any moment, any point of time you think you have not understood, I will rather go slow, but whatever you understand here, you take it really, really seriously. So any moment, just stop me, don't hesitate. All right. I have been taught by two Nobel laureates in economics. And in econometrics, and at least in the past 20 years, as far as I know, and there are at least 4 Nobel laureates who have won Nobel Prize in economics, but their specializations were in econometrics. One of them you must be knowing, Boleslav, Arch-Garch model you might have, autoregressive conditional heteroscedasticity model. And the inventor of that model, Tim Boleslav, I was taught by him. So he is the one who got Nobel Prize in economics in 1994. So you will come across a number of names who have won Nobel Prize. Because with those inventions, they have really tried to characterize the lot of behavioral complexity in finance and economics by their methods. So it's really, really nice stuff. So that's why I want you to enjoy, my friends. Okay? If I have done PhD in econometrics. If I want, I can just go on deriving equations, but it is not of no use to you. What I really want is that little by little, you understand the concept. Then only when you go back home, you feel happy. When you open the textbook, okay, this is what Tapas explained. This is what I understand now. Okay? So you will have a logical connection between what you learn in the classroom and your reading at home. Okay, so this is that's why I'm saying you are more important to me. It is not important at all how much I know. This is not very important. You know, in the past, I have won distinguished teaching award, vice chancellor award for best teaching in econometrics a number of times. But it doesn't matter to me. What is more important? Every class is a new challenge to me. When I see your face, your mind, your knowledge, it's a new environment to me. And I just try to make best use of this environment. Given your knowledge, your idea, I try to teach accordingly. Okay? So you are more important to me than anything else. Whenever you don't understand anything at any point, just stop me. Now, let me go ahead. Let me also remind you something. Sometime I will keep writing in the word file some explanation, some jokes or whatever, which will relate to your understanding. At the end of the lecture, maybe after 2-3 lectures, I will post this one in the black, so that you can probably make a logical connection between what you learned and all those new news, interesting stuff. A final point before I go back to my lecture, a small question. And that question relates to your friend. What's your name, my friend? What's your name? Okay. She asked me a very, very interesting question related to her own work. This one, all of you, I'm sure, will be facing when you will be doing your dissertation or writing your coursework for this course or in some other courses. Let me give you a small example. Assume that I have a variable y. Say this variable is called stock price. Okay, let's say stock price. So I have this stock price data for say Google. Okay? And this price is 33,690 say today. Okay, say 28,560. Likewise, some big numbers. Okay. Then I have some variables x1, x2, x3, likewise. x1 say inflation. You always know that stock prices are always governed by inflation, price. Let's say the stock price for UK and the inflation for UK, for example, here it is 4.2%, 3.9%, and then you have money supply. So in an economy, stock price is always governed by the supply of money. Okay, we say money supply. Say money supply for this month, say 1,086,000. Okay, some pound. And then say here we have 2,090,506, something like that. Okay, some big numbers. So see, you have some data where your dependent variable has big numbers. One of the explanatory variables, it has small number, 4.2, 2.3, like that. But some other explanatory variables with very, very large number. Then I asked you, can you do this regression? So you just regress. So you use the scatter, so you give a command called ls. So you have stock price, say y, then you have constant, and then you have x1, x2, x3. You put this command, and then you have some results. But what you forgot here is to transform the variables. Why? Because this variable y, it has very, very large observations, large numbers. x1 is okay, 3.9, 4.2, smaller numbers. x2, very big numbers. But then, when you do least square estimation, the output you get, the standard error, become either extremely large or extremely small. It's very difficult to explain. So what you need to do is to transform the variables into logarithmic form. And in this context, I have a question. The question is this. If my original data is not normal, okay, so my variable x, let me say this is not normal, but I can transform this in such a way that it can be normal. How do I do that? If a variable or a time series is not normal means it not non-normal distribution. You know what is not non-normal distribution? A non-normal distribution can be something like this or something like this. Skewed right, skewed left. These are all non-normal distributions. So non-normal distributions means what? If some variables are, some observations are skewed right, what does that mean? Many observations are clustered at one point. One of the very nice examples of this one, have you ever pelted stones in any mob? No. But in London, a couple of years ago, you might have heard the news, there was a very big riot in London city, and people were pelting stones, and there was an employee from the United Nations. She was passing by. So she saw that all these people are pelting stones on somebody. So she also picked up a stone and she started pelting. What is important here is not that why she pelted a stone. What is important here, did she use rationality here? That sometimes we just follow the mob behavior. Leader. If somebody is in front of me, somebody is pelting, I also just do I just follow exactly the same thing. There is no time of thinking, no time for thinking. So that type of behavior appears in the finance market. Like, say, stock prices, the distribution of stock prices, you will always find something like this. Okay? Like that. Large number of observations are clustered everywhere here. While the mean is here, the median of the distribution of cluster, what we call them? Cluster. Whenever there is a cluster defies the norm of rationality. Okay? Whenever there is a cluster, there is no rationality. That's why in econometrics, I will teach you later on, arch model, Lagrange models. Those are non-rational models. Okay? So this is not normal. If we have a non-normal variable, there is a way to transform the variable into normal distribution. And that one is called log normal distribution. Log normal. Means if you transform the variable into log, you can retain exactly the same property of the data, but the variability of the data will become smaller and smaller and smaller. Let me show you this example here again. We have 125, a big number. Another is here 80. Another is 546. Do you have in your phone, can you tell me what is the log of this variable, please? Just if you have a phone, can you anything that you have? When you have a laptop, and just can you tell me what is the log of this variable? So log of 125, maybe something 3 point or 2 point, something like that. And 80, say 1 point something, 546, 3 point something like that. Okay, try to find out.
Natural log.
What is this one?
2.09.
Okay. Say for example, and this one 80 is 1.9. Very good. 546.
2.73.
Sorry?
2.74.
No.
2.74.
2.73. Okay. Now tell me the difference. So this is x This is log x. If I plot this variable, okay, over time, let's say I have time period t equal to 1, t equal to 2, t equal to 3. Let me plot this. So I have, so time here, so 1, 2, 3. So maximum, say for example here in the scale, I have 600 maximum. So 125 for t equal to 1, say let me divide this one, 100, 200, 300, 400, 500, 600, okay? So 125 somewhere here, okay? 80 somewhere here, 546 somewhere here, okay? So see, let me join the lines. So the fluctuation is too big. Now let me plot this one. So t equal to 1, t equal to 2, t equal to 3. So maximum is here 2.73, maximum 3. So 1, 2, say 3 here. So 2 somewhere here, 1.9 somewhere here. So 2 here, this is for 1, 2, and 1 point for this one, 1.9, 2.73. So for t equal to 3, somewhere very close. Now see, so this is original variable. This is log transform variable. If I take the distribution of this variable, the distribution will be right biased because one of the variables is extremely large. Okay? One of the numbers extremely large. But if I take the distribution of this one, it will be something. So that is what we call log normal distribution. In practice, if you have a variable which is non-normal, skewed right, skewed left, you can transform them into log, and that distribution you can get a log normal distribution. Okay? What is the formula, do you remember? Any formula for a normal distribution? That's a tough question, isn't it? Well, I can write this for you. A normal distribution follows something called a Gaussian distribution. Okay. Gaussian distribution. And the formula so that is actually the formula for a normal distribution. This is a constant, the exponent of the variable minus its mean divided by its variance. So that is how it moves. Now in that context, again, I need to ask a small question again. What is e to the power 0? Equal to 1. This is natural logarithm. Then you have another log. Log at base 10, this is e. Okay? And if I just write log of exponent of x plus 2, can you tell me what it is?
Plus 2.
X plus 2? Exactly. Why it is so? Because I have a base here. What? So x plus 2. But when I have log 10, so the variable or the number becomes bigger. With log e, the number becomes, what is the exponent, value of exponent? E equal to 2.71828, like that. After that I don't remember. But there is a mathematician in India, Professor Ramanujan. So he is just like a supercomputer in his brain. So he remembers about 10,000 numbers after 2.71828. He remembers everything. But he was also one of the person who discovered that one. Anyway, So now you remember that whenever we have a variable which has extremely large and small observations, means lot of fluctuations, when you are doing empirical analysis, you can transform the variable into log so that all the variables in your data will be well behaved. Okay. So that one concerns you. Okay. Now you have understood the basic concept of distribution, mean. Yes, for the final question. What is a variance? Then I will go back to my lecture. So I'm 2 hours I spent just explaining the very basic stuff. Because you know, whenever you go to a GP, if I go to a doctor here and I say, doctor, I have heart attack, then he will not give me any medicine for heart attack for the time. What he will do? He will do preliminary check. He will test my blood pressure and insulin level, all these preliminary checks, my heart rate, everything. Then only if he is convinced that I have all the symptoms for a heart attack, then he will give me something, some medicine. So I am just exactly doing the same thing here. Before teaching you all the advanced materials of time series, I am ensuring myself that you know all the relevant basic concepts very clearly. And then we can proceed. So my last question is about the variance. What is variance? Or standard deviation? So standard deviation, if I write sigma, variance is sigma square. Okay. So what is standard deviation, by the way? What are the represent? Don't need to tell me the formula. I will write the formula. But whenever you have heard about the concept of standard deviation, what does that mean?
Spread.
Tell me. No, there is nothing to panic. So anything that comes to your mind, tell me. Standard deviation represents
Measure
the
the spread of the data.
Yes, it's a kind of difference from the mean or distance from the mean. Standard deviation in real life represent the estimates of reliability. The bigger standard deviation you have, the higher is unreliability. Higher is the imprecision. Smaller standard deviation means more precise. And the smallest standard deviation one can have, we can say unit standard deviation. Say over time, a variable increases by 1%. Say, let's say like this. This year, you are getting your living expenses are sponsored by your parents. So this month, your parents sent you 2,000 pounds. Next month, they increased only by 100 pounds, 2,100. Following month, 2,200. It is going. They are trying to adjust the inflation so that the 100, 100, 100. But if you are the most adorable daughter or son of your parents, they might, okay, take 5,000 pounds, go to Spain and spend your holidays. Okay? The variability is greater. But if there is 100, 100, 100, it is unit standard deviation. The fluctuation is not too much around the mean. Okay? So standard deviation, in this case, say, if you have a normal distribution and x bar or mean is here, so x bar plus standard deviation, x bar plus 2 standard deviation, then x bar plus 3 standard deviation. Similarly, here, for a normal distribution, x bar minus 3 standard deviation, x bar minus 2 standard deviation, x bar minus standard deviation. You know? So for a normal distribution, x bar plus minus 3 standard deviation is what we call a normal distribution. Okay? So standard deviation represents precision, reliability, or distance from the mean. How far you are from the average. Okay? If the average is say 5 and you are, for example, 9 here, so 4 should be your standard deviation. So how do I calculate standard deviation? Normally, how do I do that? Say standard deviation, the formula is root square root of, yes, tell me, anybody? So square root of, if I have a variable x, So standard deviation can write sum of, yes. So if I had xt minus its mean, okay, square it divided by the number, and if I have the variance, so I just need to take it. That is the variance. Okay. So essentially, it means if this is my mean or average here. So how far each observation is away from the mean? That distance. So higher is the distance, higher is imprecision, higher is unreliability. That's why you are calculating standard error of a distribution, standard error of a statistic or parameter. You have seen that in the standard error. Standard error means standard deviation, estimated standard deviation. So whenever you have extremely high standard deviation, that means you cannot rely on the estimates of the parameters. So essentially, what we always want, smaller and smaller and smaller standard deviation. But there is a limit. If standard deviation is almost zero, it's not good. It is too precise. And it is extremely large, too imprecise. There has to be some balance in between. I will teach you those things in the course. So this is the rule of standard deviation. So remember that whenever standard deviation, say for example at time t, variance of a series at time t, it tends to infinity. So think about a world wherever the variance of political situations, the variance of terrorist attacks, it is always tending towards infinity. So we are living constantly under threat and fear and vulnerability. I must admit something that about 20 years ago, 10-15 years ago, we never heard of all the terrorist attacks, that, never heard those things so frequently. Or in the newspaper, CNN, BBC, just open a newspaper, the first thing that comes, there were say 10 people, 50 people shot dead in US. Those many people are dead because of terrorist attack in Afghanistan, India, everywhere. So those things are very frequent these days. So that means the variance is tending towards infinity, extremely large. 10 years, 20 years ago, it was too small, some finite number. Okay, so nowadays it has become very large. So always try to remember or interpret any statistical concept in terms of realistic thing. Then you will see, oh, whatever equations I see, okay, I can relate this to the real one phenomenon. Okay. Now I will stop those things now here. So more or less you know those things. So let me go back to the lecture. So in today's lecture, although I have about 10-15 minutes left, but I will try to explain some part of that. So it is about trend and seasonality. Okay. So this is about time series. So I will only focus on a single variable x or y which is observed over time and its behavior. So how do they behave? It is about behavior of a time series, many time series that have very common tendency of growing over time. And therefore, they contain a time trend. For example, when making a very causal inference, we may falsely conclude that change in x is actually caused by change in y. If we have a trend component, let me show you this graph, how you can understand. You have seen this type of behavior in any times, sales, inflation, money supply, stock prices, growing over time. This type of thing you might have seen. So this type of graph explains two things. That in the context of a time series, remember that a time series is always guided by these four components. Always. Anytime it has a trend component or long-term trend T, it can have a cyclical component. called C, a seasonal component S, and a random component R. So basically, any time series that xt, so you can write it has variable called xt. So it has say trend component plus, then you have cyclical component, then seasonal component, then I have random component. So it's a mixture of all these components together. Sometimes I can write this one, multiplication, multiplicative effect. Okay, why this one? Sometimes trends, cyclical effects, seasonal effects add to the variable. Sometimes it appears in a multiplicative form. Now, let me give you an example of a cyclical component or seasonal component. You know, every year during Christmas, we tend to spend more. Whenever, and these supermarkets are also very clever people. I remember that 10 years ago, about 10 years ago, they never had the supermarkets. There used to be Mother's Day, Father's Day, all these Easter egg, that everything. So these days they are advertising a lot. So before the Easter comes, you will always find in top supermarket, Debenhams, these days, go to Westquay, everywhere. You will find big billboards advertising, Easter is coming. So be prepared to spend. Okay? So every year, during some specific season, we have a tendency to overspend. And you'll be surprised that about 90% of the people in UK, it has from a consumer survey, they have found out on the credit card, they're in a debt. They spend so much in buying gifts during Christmas. In January, there is absolutely no money left in their bank account. Of course, it is for the common people like us. Okay? But, so see that there is a specific pattern during a specific point of time in the year where we spend more. And there are some specific days, specific point where we spend less. So, let's say, buying gifts or spending heavy. We are looking at the spending heavy of people. So this spending heavy is a seasonal component. It's a seasonal component. So what is the seasonal component? That in December, during Christmas, spend more. And if you are married, you have a child, then you have all the occasions. My daughter asked me, my daughter is 7 years old, and there are a couple of days, yesterday there was a Mother's Day. So obviously she doesn't have money, so she had to buy something from my pocket. So I had to buy some gift for her mother, means my wife. And so there is a seasonal component. So these components, it keeps on occurring all the time. So spending heavy is seasonal component, so this is S. But among all those things, season, cycle, random component is error term. Okay, random. You have no structure. What is more important in time series is called something called trend. What is a trend? Trend is one of the most interesting econometrics or statistical concepts in the context of time series. Let me explain what is trend. Think about this graph. So we have time here, cells. And all these dots represent low, high, low, high, low, high. Means in a particular time of the year it goes up and comes down, goes up and down, like that. But if you draw a trend line, it is showing an upward movement. Now, forget the context that it is sales. Let's think it's GDP, real gross domestic product. You have heard about this term, like national income growth of a country. Okay, so that could be what the interpretation of trend. So in essence, what you see from this graph, trend means either upward or downward. Okay, trend can be either upward or down. It can be like that. But what does it imply? It is just not a statistical concept. When we include a trend in a time series, it implies a lot of things. For instance, if I have GDP, gross domestic product, or income of a country, okay, and income of a country or gross domestic product of a country, it always increases, right? Although it's smaller amount, sometimes because of financial crisis, this, that, but it always increases. So we can always find a trend. Say GDP is increasing like this, and this is the trend. So this is GDP, falling up, like that. So over time, the GDP is increasing, and if we fit a trend line, it is a straight line going up. So subtracting a trend from the growth of a GDP implies trend represents what? Is it what trend implies? Independent, exogenous, or endogenous element which motivate the growth of export, independent of what is happening around. See, a country is growing. Technology. Technological growth is one factor which helps a country to grow more. So whenever I see trend in national income of a country, so that trend represents a technological growth, financial structure. So trend is something very important to the growth of a time series, which can always be some exogenous elements, something happening. God has blessed one country so much with natural resources. You know, there are some countries in the world which are extremely endowed with a lot of natural resources. Oil, these are Arabian countries, lot of oil reserves. Whatever you do in life, you cannot change their geographical structure unless you attack them, okay? But there will be oil all over the world. And so, but in those specific regions in the world, there will be oil reserves more and more. So that trend represents that independent factor. And now the country has to work hard in terms of financial level, stock market level, political level. These are different factors. But what are that trend represents the independent, exogenous or endogenous factors, which is always there, irrespective of what is happening to the series in the long or the short run. So this is what is called trend. So whenever I just write a variable like this, y equal to alpha plus say beta 1 t plus beta 2 say xt plus epsilon t. So in this case, what did I do? I want to explain y at time t. I am explaining y with an intercept. Then I am including a trend term. Means the growth of y is always governed by some independent factors. Then I have some variable x. So in this case, if I have a time series, it is always useful to include a trend term t in the regression process. Now, can you explain something to me? What is the role of an intercept in a regression? You have done that, right? Number of times you have included an intercept. Assume that I don't have it here. What is the problem? I don't have any intercept in a model. So what does the intercept mean? Give me an example where you can find no intercept. Can you really find it? Can you really describe the growth or any regression form like this without an intercept? As far as my knowledge is concerned, in social science, this is not physics. In physics, yes, we can discuss some elements, but intercept means some independent factors, right? So those factors remain constant. That is what I mean. That's what called. With this example, probably you will understand the role of I always give this example. If this is consumption, yes, consumption, you consume. So this is alpha plus beta income. So your income rises, consumption rises. Income falls, consumption falls. Assume that at some point of time you have no income. So if you have no income means say x is 0. So x times 0, x equal to 0, 0 times beta, this is also 0. So this component is not there. So consumption is equal to alpha. So what does that mean? That in order to survive in the world, you must eat something, right? And to eat, whether you have income or not, you can kill people or you can steal from somebody else. Whatever you do in life, honest means or by dishonest means, you must survive. And that survival tendency is explained by alpha here, intercept. So whether I have, if my income, I have 0 income here, no income. So if I don't have any income, I can steal from people. That is the role of an intercept. Okay? So in social science, any financial, economics, or political variables, if you want to do regression, you must include an intercept. So intercept means independent. So independent of the variation of x, what is motivating your growth of consumption is also alpha. Your tendency or inertia to survive, survival tendency is common in every human being, in every animal, in every living being. You might have heard in ancient times, whenever people used to travel by boat, long distances, whenever we didn't have these flights and those things, they used to travel long time by ships. And at some point of time, they used to finish their stocks. And you know what they used to do? They used to kill people to eat. There are some, recently, they have found some in Ivory Coast or somewhere, they found, yes, this lady knows, they found a boat full of human skulls. So they have discovered that humans were killing other people just to eat their fleshes to survive. So that is intercept. Okay, that survival tendency in any time series, in any variable, it's called intercept. Okay, and then whenever that tendency, this is independent factor, social, cultural, economic, political, something very independent. But something, some natural reserve, something that grows over time, but it is specific to that country, to that variable. That is what we call trend. Okay? So trend means it always grows up or down. But this one you cannot determine. It has to be there. Trend you can determine. It's space. You just accelerate innovation, adopt new technologies, adopt new banking mechanism, banking efficiency increases, financial efficiency increases. Those things can contribute to the growth of the trend. So that's why you can always dissect any time series into 4 components. One of them is this trend component, long-term trend, cyclical component, seasonal, and random. Okay? So I will stop today with this introduction, but I will come back next week to explain more about those things, but I will not spend more time on these things because in the exam I will not put anything from here, but it is just for your understanding. Then after next class, I will take seriously other subject areas like metro, ARMA, stuff, but try to read as much as possible in the blackboard. You have everything. Just read those things before you come to the class. Okay? Thank you.